of the thrust right now within the Aeronautics Research Mission Directorate is looking at what they call N+3, or way out there, like 25, 30 years out there. What are airplanes going to look like? What are the engines going to be? How are we going to get from, say, Atlanta to Seattle, right? What are we going to be doing? Is it still going to be tube and wing, or are we going to go with some advanced configurations? This is one of those advanced configurations. This is a box wing.
Oh.
Thank you. And this obviously is not a commercial airplane. This is a much smaller version of it, but you can get the gist of this. If you scale this up a bit, you can start to see how this could be applied then to an actual commercial aircraft. This is just one of the, this is an older configuration now, but NASA currently is looking at a couple of N+3 configurations. One of them is a box wing. There's another one that's a truss-braced wing. You can go to the ARMD website on NASA and you can actually see what those N+3 configurations look like. This one, however, is a very early one. This one we ran, I want to say, probably close to about 10 years ago. But anyway, all water tunnel models, all just kind of fun stuff. I also have a couple books here. Flow visualization is very, very popular in general. They use it for a lot outside of aviation. It's used in general in a lot of applications. And that's kind of what this book is about. Any questions before we turn the tunnel on? When it gets loud.
Turn the tunnel on.
What happens to the dye in the water as it runs through the tunnel?
Great question. The dye itself just stays in the tunnel. We have enough water that it just kind of gets diluted. We can run the test section full dye going for probably about 3 hours before we start to really see a lot of the dye in the water to where we want to drain the tunnel. Back in the day, back in the 80s, when this facility was like used all the time, like here, now we're lucky we run it, a couple times a year, just because of how far computers have taken us, basically. This doesn't replace the computer, but this will go a long way to validate what we're seeing out of a computer. Back in those days, obviously, you didn't have CFD, you didn't have computational fluid dynamics like you do now. So in those days, this thing would run like almost 2 shifts. It would run a lot. And so dye became a very real problem because the 20 minutes it took to actually drain it, and then the 40 minutes it took to reconfigure it, and that was real time. So we actually developed a scrubber system, a filtering system where the water would just get filtered. Great question. We don't use that anymore, but yes.
Now the large structure here, that's not the test section. Is that meant to make the water flow laminar or get the disturbances out of it?
Yes. Basically, this up here is the actual chamber. That whole thing, like the lightish, yellowish, greenish, wood panels you see there, that is enclosing the actual water tunnel tank. So we have filled that up. That is pretty much filled probably to within about 1 foot of the top of what you see. And then the water actually flows down to the test section, which is right here, and then it flows through a series of pipes and goes right back to the bottom of the tank, and then it just gets recirculated like that. We look at the flow quality on this, or let me rephrase that. The speed of the tunnel is what we vary to get the flow quality that we are looking for at any given time. So for this one, when we turn it on, it's going to be running at right around 7 inches per second. That doesn't correlate with any specific flight condition. It doesn't correlate with a speed or an altitude or anything like that. It's completely qualitative. We're not taking actual physical measurements off of this airplane. We are just looking at those big, large scale flows like vortices to see how they interact on the airplane. That's it. And so we're looking to basically get those vortices in there and to get the dye as well flowing so that we can really see those vortices and we can make them come out. Any other questions? Those are great. Awesome. All right, we'll get